This question is saying let A1, A2, A3 be in arithmetic progression with A1 7, common difference 8. So terms T1, T2, T3 be such that T1 is 3 and this relation is followed, n is greater than or equal to 1. So you have to find out the correct statement out of the given statements, right? So what we should do now, this thing here is Tn plus 1 minus Tn is an, right? So using this, and n is greater than or equal to 1. So starting from 1, for n is equal to 1, I can write T2 minus T1 is A1, n is equal to 2, T3 minus T2 is A2, and likewise. Okay, so for n is equal to n, we can say Tn plus 1 minus Tn is equal to an, right? So if I add them all, right, you see on the right hand side, this is sigma A1 plus A2 like this until an on the right hand side. And on the left hand side, what is happening? Getting cancelled. This will get cancelled with this one. This one will get cancelled with this one, right? Here we have Tn minus Tn minus 1, right? So what will be left with is Tn plus 1 minus T1 is equal to A1 plus A2 plus A3 until an, right? So from here what we have got is Tn plus 1 minus T1 is equal to sigma I can say, right? If I is from 1 to I is equal to n, that is A1 plus A2 until an, right? T1, the value is given. T1 is 3, right? So from here only I can say, and see, this AI, A1 plus A2 until an, A is an arithmetic progression, right? So this thing here we can find out, right? This is simply the sum of the AP until n terms, right? So the number of terms is n terms. First term is 7. Common difference is 8, right? This thing here is straight away the sum of AP, right? So for n terms, the sum is n by 2 times first term plus the last term of the AP. First term is 7 plus the last term is 7 plus n minus 1 times the common difference, that is 8. Okay, that is given to be 8. Okay, so simplifying this will give me n by 2 upon 14 plus 8n minus 8, right? That is n by 2, 8n plus 6. That is n times 4n plus 3, right? So this thing here I am getting as n times 4n plus 3. Okay, so now I can say this T1 is 3, right? That means I can say now that Tn plus 1 is equal to this thing plus I bring T1 this side. So this is 3 plus n times 4n plus 3, right? So now we have an expression for Tn plus 1, term number n plus 1 in terms of n. Okay, right. So now I have the expression for Tn plus 1, that is coming out to be this 3 plus n times 4n plus 3, that is 3 plus 4n square plus 3n, isn't it? So term n plus 1 is 4n square plus 3n plus 3, right? And in the options, it has been asked the value of T20 and T30. Okay, we'll try to evaluate T20. That is for n is equal to 19. So I'll plug 19 here. 4 times 19 square plus 3 times 19 plus 3. That is equal to 1504. So T2 is coming out to be 1504, but the option says 1604. So certainly this is not a correct choice. Okay. Next we'll find out T30 and see if it is correct. Okay. So T30, if I try to find out, that will be for n is equal to 29. Okay. So this is equal to 4 times 29 square plus 3 times 29 plus 3. Okay. This is coming out to be 3, 4, 5, 4. That means yes, option number C is a correct choice. Okay. But since this is a multiple choice option, we have to check the other options as well. Okay. This is multiple choice question where we can have more than one answers. Right. But here now we have to find the summation of the TK series. Okay. TK, T I have in terms of n. So Tn plus 1 I have 4n square plus 3n plus 3. I have to find the summation of that sequence. Okay. So next I'll check the summation of the sequence T. Okay. But here I have summation of Tk, right? And we have the expression for Tn plus 1. So I have Tk plus 1, I can say, is equal to 4k square plus 3k plus 3. Okay. So let's convert this to Tk. Okay. Now see, if I replace k by k minus 1, what will happen? This thing here will become k. Okay. And all the things will change accordingly. So Tk minus 1 plus 1 is equal to 4k minus 1 whole square plus 3k minus 1 plus 3. Okay. This tk minus 1 plus 1 is nothing but tk. Tk is equal to 4k minus 1 square plus 3k minus 1 plus 3. This is equal to minus 3 plus 3. This is equal to 4k square plus 4 minus 8k plus 3k. 3 minus 3 gets cancelled. Okay. And this is finally equal to 4k square minus 5k plus 4. Right. So I have the expression for tk now. Right. So once I have the expression for tk, that is 4k square minus 5k plus 4, I can evaluate this sum of the series. This series I can evaluate. So sigma tk, k going from 1 to 20, okay, that is nothing but 4 times sigma k square. The limits are the same, k 1 to 20, minus 5 times sigma k from 1 to 20 plus sigma of 4, again k from 1 to 20. Now you see, this is sum of the square of the first 20 natural numbers. This is the sum of the first 20 natural numbers. And this is like 4 into 20 straight away, right? So this is equal to this sigma tk from k1 to 20 is equal to 4 times this thing here is k into k plus 1 into 2k plus 1 upon 6 minus 5 times k into k plus 1 upon 2 plus this is 80. Okay, this last term is 80, right? Okay, so I have sum of tk from 1 to 20 as this. So k is going from 1 to 20. I'll put k is equal to 20 in this one. Okay. So 4 times 20 times 21 times 41 upon 6 minus 5 times 20 times 21 upon 2 plus 80. Okay. This will simplify to 10510. So certainly option number B here is a correct choice as well. Okay. Now finally let's evaluate the option number D to see if it is correct. Okay. Right. If you have to find the sum of the same series for k going until 30 here. So what I have to do, simply put this value of k is 30 here. Okay. So that is 4 times 30 times 31 times 61 upon 6 minus 5 times 30 times 31 upon 2 plus 80. This will come out to be 35615. Okay. And in the option it is given 35610. So certainly this is not a correct choice. Okay. So we are left with our two correct choices, B and C. So answer here becomes B and C for this question. Okay. Thank you.